Yes. Here is another simple algebra problem that has come in CAT 2001. There is a change making machine that contains rupee 1, 2, and 5 coins. The total number of coins is 300 and the amount of these coins is 960. For example, if there are 200 coins of 2 rupee denomination, then they will contribute to 200 rupees. Right. So, what are there are these three different types of coins, right? Let's assume if there are X coins of 1 and Y coins of 2 and Z coins of 5, then total number of coins X plus Y plus Z is 300 and the value of these coins is 960, right? And if 1 and 2 are exchanged or interchanged, the number of coins and interchanged, then the value is coming down to by 40. Coming down by 40 means 960 minus 40, which is 920. What are the total number of 5 rupee coins? Right, it's just about writing some basic equations. Now, 1 rupee coin, 2 rupee coin, and 5 rupee coins. Let's assume there are x of this, y of 2 rupees, and z of 5 rupees. So, total number of coins 300 means x plus y plus z equals 300. Now, this x coins of 1 rupee, what is their value? X into 1, which is x. Now, y coins of 2 rupees, how much value do they will it contribute? It is 2 y rupees. For example, if there are 50 coins, the value will be 100. There are 100 coins, the value will be 200. And Z coins of 5 rupees. What is their value? Z into 5. Right. If there are 50 of Z coins, 50 coins of 50 coins of rupees 5, then total will be 250. So 5Z. Right. Now this total is 960. Now 1 rupee and 2 rupees are interchanged. That means instead of x rupee x 1 rupee coins, there are x 2 rupee coins. So the value will be 2x, right, of these 2 rupee coins. Instead of now, and y 1 rupee coins. Y 1 rupee coins will contribute to y, and x 2 rupee coins will contribute to 2x, and 5 rupee coins are still z, it is 5z. So y plus 2x plus 5z is 40 lesser than 960, which is 920. We have these three equations. These three equations only: x plus y plus z equals 300, x plus 2y plus 5z equals 960. And let us put it in the different order: 2x plus y plus 5z equals 920. We just need to solve three equations, three unknowns. How do we solve this? Let us eliminate x from first two equations and then second and third equation. First, let's subtract first one from the second one. 2y minus y. X minus x is anyway 0. 2y minus y is y. 5z minus z is 4z equals 960 minus 300, 660. Right. Then let's eliminate x from these two equations. What do we do? Let's multiply the first, second equation by 2 times. Right. And then subtract the third equation. That is 2 times of x, 2x minus 2x, which these two will cancel. 2 times of 2y, which is 4y minus y, which is 3y, and 2 times of 5z, 10z minus 5z is 5z, and 2 times of 960 minus 920, which is 1920 minus 920, which is 1000. Right. We got this equation and this equation. This one from first two, this one from second two. Right. Now let us try to eliminate y out of these two. So let us multiply this equation by 3 times. 3y plus 3 fours 12z becomes 3 660, which is 1980. Let us subtract this one from this one now. 12 3y minus 3y is 0. 12 minus 5 7z equals 1980 minus 1000, which is 980. That means z is 140. If z is 140, y is 4 into 140. Y is 660 minus 4 into 140, 660 minus 560, which is 100. And x plus y plus z is 300. 140 plus 40, then remaining should be 300 minus 240, which is 60. So there are essentially 61 rupee coins and 100 2 rupee coins and 145 rupee coins. This is that simple problem. Only thing is we need to be able to write these equations and solve. Right, guys? Thank you.